Hello dear student, welcome to our class. So today we are going to discuss the class 11th chapter number 1, which is mole concept. So first of all, we have understand the meaning of mole. What is mole? So in definition, mole is mole is it is a counting unit. It is a counting unit in which in which one mole one mole equal to Na particles. Na particles. So here is the basic definition of mole. Mole is what? It is a counting unit in which one mole is equal to Na particles, where Na denote what? Na is equal to 6.022 into 10 raised to power 23 particles. So here we use a term particles. Let me focus on it. What is particles? Particles is electrons, protons, atoms, molecules, ions. So these all are called particles. Suppose in a room you have 6.022 into 10 to raised to power 23 hydrogen gas molecules, which is equal to what? 1. Okay, let us have some example about. Suppose you go the shopkeeper and ask him, please give me 1 dozen of banana, yeah, 1 dozen of pen. So he will give you 12 piece of pen. What? 12 piece of pen. Okay, so in any room, any system, it will be so if there is a mole of any particles, it will be equal to what? 6.022 into 10 to the power 23, which is a counting, which is a countable. Let us have some example about 1 dozen pen, which is equal to 12 piece. So 2 dozen of pen, which is equal to 2 into 12 piece. So if we have n dozen of pen, which is equal to n into 12 piece. Okay. Suppose you have 1 dozen of pen, which is equal to 12, which is a countable number. If you have 2 dozen of pen, which is equal to 2 into 12 piece, which is also countable. If you suppose you have n dozen of pen, which is equal to n into 12 piece, which is also countable. If I ask you, can you tell me how many pens is n dozen? So you will tell us, sir, it is n into 12. So if n dozen, total number of pen is what? N into 12, which is what? Total number of pen. So by this basis, we can use these tricks to calculate the first formula of mole concept. So let us see. Suppose suppose we have 1 mole of atom X. A particle X, particles denote electron, proton, hydrogen, atoms, ion, molecules, etc. Suppose we have 1 mole of X, which is equal to what? Na number. Na number, we can see that it is a counting unit in which 1 mole is equal to Na particles. So in a room, we have 1 mole of X, which is equal to Na. We have 2 mole of X particle, which is also equal to 2 into Na. If we have n mole of X, which is also equal to n into n. Okay. Let's first of all, 1 mole of X particles, which is denote Na, 2 mole of X particle, which is also denote 2 into Na. If we have n mole of X, which is equal to n into Na, and if I ask you how many particles in n mole, so you will tell us, sir, it is n into n. So by this, n into Na is equal to total number of particles. What total number of particles? So n into Na is total number of particles in n mole. By unitary method, we can see here n into Na is equal to what? Total number of particles in n mole. In n mole. Okay. We can assume total number of particles in n mole is equal to capital N. Okay. So by unitary method, n into Na, which is equal to capital N. So in this, we can calculate n mole, which is equal to n bata Avogadro. Okay, where n denote what? Mole. Where capital N is what? Total number of particles. Or Na is what? Avogadro number, which is equal to what? 6.022 into 10 raised to the power. Okay. So by this, you can calculate mole. If you have given total number of particles and you will divide it 6.022 into 10 raised to the power 23, you will find the sample of mole. Yeah, how much sample present in there. Also, let us have some example here. Suppose we have 18.066 into 10 raised to the power 23 H plus ion. Okay. So we have find how many moles are H plus ion present in a sample. Okay. So here this value is given at what? Total number of particles of H plus ion. So capital N is equal to 18.066 into 10 raised to the power 23. Okay. And Avogadro number is what? 6.022 into, and here mole is equal to 18.066 into 10 raised to the power 23 divided by 6.022 into 10 raised to the power 23. Here is 23 cancel up and we can divide it 3. So our mole is comes out, which is equal to 3. So in this sample there is a 3 moles. So you have understand it. Let us have some another example. Suppose we have 12.044 into 10 raised to the power 21 CO2 molecules in a sample. In a room, suppose you study in a room and here 12.022 into 0044 into 10 raised to the power 21 CO2 molecules present in your room. So your father asks you how much CO2 molecules present in your room. So we have seen their formula, moles is equal to capital N upon Na, where capital N denote what? Total number of particles, and Na is what? Avogadro number. So here we can divide it 12.044, which is equal to capital N 10 raised to the power 23, and we can divide it 6.022 into 10 raised to the power 23. Here 6 comes out 2 times, and 23, which is going to upper 2 into 10 raised to the power 21 into 2 raised to 10 to the power 23. So it is comes out 2 raised to 10 to the power 20 minus 2, and here is our answer. So in a room The number of CO2 molecules is what? 2 into 10 raised to power minus 2. Okay, thank you.